The goal of this project is to create a model that will be able to recognize and determine the handwritten digits from its image. The MNIST database that we will be using in this section is a large database of handwritten digits, commonly used for training various image processing systems. The major goal of the proposed system is understanding XGboost and applying it to the handwritten recognition system. We will be performing the following steps to train and test our model for this project. Let's begin with the environment settings by starting with importing the necessary libraries required to run the project successfully. So here I have imported all the libraries. All are the ones that we have been importing till now for all previous projects as well. Next, I will specify the S3 bucket where we will store our models for this project. So I have already created the bucket with the name MNIST-SM, and then the prefix I have used is SageMaker/XGboost MNIST. Then we stored the execution role in the variable role and the region name in the region variable. These two together are then used for the bucket path. Now let's run this. So in this project, we will use a different method to import the dataset in our notebook. In this session, we will look at how you can import the dataset to your Jupyter notebook directly from a downloadable dataset web URL. This is the link here from where we will download the dataset. But this time, instead of manually doing it, we will see an automated process for this. So we import these libraries here in this cell, where Python pickle module is used for serializing and deserializing Python object structures. Python gzip module is the interface to gzip application. It is used because our dataset will be in a zipped gz format, and this library will be used to unzip the contents. Then we have the URL lib.request module that defines functions and classes which help in opening URLs available on the web. Then we have some common libraries for JSON and NumPy. So moving forward in the next cell, we have the payload URL, which will be our main web URL from where the data needs to be downloaded. And the file name that is available there is mnist.pkl.gz. Now that we have defined the payload URL and the file name, here line 6 of the cell is responsible to fetch the provided file name from the URL. Once that is done, the file is then unzipped and opened, and the training dataset, the validation dataset, and the test dataset are extracted in their respective variables using the len1 encoding. Now let's run this cell and then see the shape of the training dataset. So here we can see the shape of the dataset. So this is how you load the dataset using the URL. In our next lab session, we will explore the training dataset. In this session, we will be exploring our training dataset for the handwritten images. The training set contains two values. One is the actual training set, and the other is the set that contains labels associated with the corresponding training images. Let's see them. Here I have imported the matplotlib for the plotting options and the raw column parameters as 2, 10. And in the next cell, for 10 random samples out of the training set, we will display the image and its label. So the image variable will contain the image and the label variable will contain the label for it, reshaping the image and then plotting it. Now let's run it. Alright, so here you can see that with each image, there's a label which tells what the number in the image actually is. Like for 0, it says this is a 0. And for each of the 10 random selection from the set, there are these two things. So basically, this is there for all the 50,000 images inside the dataset, the training image and its label. So this is what the training set contains, and in our next lab session, we will start with training the dataset using the XGboost algorithm. In this lesson, we will look at how to transform the training dataset. But before that, let's quickly discuss the XGboost algorithm. Basically, the XGboost, which is short for Extreme Gradient Boost, is an optimized distributed gradient boosting library. It implements machine learning algorithm under the gradient boosting framework. XGboost provides a parallel tree boosting that solves many data science problems in a fast and accurate way. The question that comes to mind is that when to use this algorithm? Well, it can be used for any supervised machine learning task that has a large number of training examples. For example, a dataset that has a few features and at least 1,000 examples, just as in our case. It can also be used in cases where there's a mixture of categorical and numeric features. Moving on to the transformation part for our training dataset, the XGboost algorithm expects CSV formatted input. For that, we will need to transform the training dataset from numpy.array format to the required CSV format before we can use it. And after transforming the dataset, we will upload the transformed dataset to Amazon S3. So here importing the necessary libraries, and then here is a function defined that will convert our data for the complete dataset containing the train set, validation, and the test set in the CSV format. Let's define this function. Now let's call this function. Alright, so now you can see that each of the dataset file is now converted and saved to the S3 path as can be seen in the output results. Now that we have transformed the dataset, the next step will be to train our model and deploy it to get the results. And welcome to this lab session. In this lesson, you will learn to train the model for the MNIST dataset using the XGboost algorithm. So firstly, we will import the necessary libraries. This time we are importing to get image URI, which is short for Uniform Resource Identifier Library. This will basically help us create pointers for referencing to the storage location for the datasets file, which we will be using for the training purpose of our model. So in the next cell, we have the URI template. So this will be our template where we have the first argument as the bucket name, the second is the prefix, and the third is for the respective datasets. The train data, validation data, and the output location as can be seen in line 345. And then I will print these three URIs. Let's run this cell. So here we get the resource location for each of the three. Next, let's set the parameters for our XGboost mode. We will use the version 1.21 for the XGboost in our current region. Then in the estimator, we will give in all the parameters in the same way we have been doing for all our previous projects. Let's run this cell. Next, we set the hyperparameters for our model, starting with the max depth, which is the maximum depth of a tree. Increasing this value makes the model more complex and likely to be overfit. And its default value is 6, but I will keep it 5 for my case. Then we have the ETA, which is the step size shrinkage used in updates to prevent overfitting. Next is the gamma value, which is the minimum loss reduction required to make a further partition on a leaf node of the tree. So the larger this value, the more conservative the algorithm will be. Then we have the minimum child weight, that is the minimum sum of instance weight needed in a child. The objective value here specifies the learning task and the corresponding learning objective. Moving on to number underscore class is the number of classes. And finally, the number underscore round is the number of rounds to run the training. Let's run it. And then we define the channels for the train and test datasets for our model training, where we give in the dataset variables and their file formats. Let's now begin the model training. So here we go. And the model has started training. And it will take a while to complete, so I will pause it here and then we will continue in the next lab session, starting from the deployed model and validating the results. In this lesson, we will look at how to bring the test dataset from the S3 to our notebook. And then, using the model we just trained, we will validate our results. So I have beforehand deployed the model here. As you can see the exclamation mark here, and you can also simply run this line in your notebook instance. We will start with validation of the results. So here we first create a test key where we will locate our test data from the S3 bucket. Alright, so let's bring in the 10 images that are on the serial numbers 0 to 9 from our test dataset we have with us. You can bring in your choice of images for that, just change the numbers here in the for loop. So this cell on execution will bring the images as well as the labels for it. Let's run it. Here you can see the labels along with the images itself. Now we will perform the prediction on the selected 10 images. So the XGboost predictor will give us the results for each one of them. Let's run it. And here we go. So we get the exact results for the prediction through our model, and we can say that the model performed quite well in classifying the handwritten images. Just delete the endpoint once you are done using the deployed model so as to reduce the incur charges. So this is how we perform the classification of images using the XGboost algorithm. With all our projects, I hope you have got a complete understanding on how to run multiple projects with different use cases on the AWS SageMaker environment. As you have noticed, the basics remain the same, just the model training and the approach to solve a particular problem changes considering the problem statement we are working on.